picture Norway from far above, the way a satellite might see it on a clear winter night. The country stretches like a long spine of stone, cut deep by fjords full of black water. Snow covers the mountains in a soft blue-white blanket. Threads of gold mark the small towns, scattered and far apart. And near the middle of the country, tucked between rounded peaks in the county of Trøndelag, there is a narrow gap in the land. This is Hessdalen from above. It looks like nothing more than a quiet fold in the earth, a small valley about 12 kilometers long, holding a scatter of farms and a slow river. There is no reason at this height to notice it at all, but drop down closer, past the tree line, past the frozen fields, down to where a person might stand at night and look up at the ridgeline, and something changes. For decades, people in this valley have watched lights appear in the sky and hang there, not falling, not streaking, just hovering, sometimes for minutes, sometimes for over an hour, over the dark shapes of the mountains. Some lights are white, some glow yellow or blue. Some seem to split into two, drift apart, then come back together like they remember each other. This valley holds one of the longest-running, unexplained light mysteries in the modern world. It is not a myth from centuries past. It is documented, photographed, and still unresolved today. Scientists have brought cameras, radar, and spectrometers into these hills. Farmers have watched from their kitchen windows, and after all that watching, the honest answer is still, we do not fully know what these lights are. Before we go further, the planet has a new, quiet wonder to share every night. If you'd like one waiting for you each evening, subscribe and let it come to you. Picture the valley itself, because its shape matters to this story. Hessdalen sits low between mountains rich in iron, copper, and zinc, minerals pulled from these hills by miners for hundreds of years. The rock underneath is old, folded, and under quiet stress from the slow push of the earth around it. A river called the Hesje curls along the valley floor, and in winter, cold air pools down there, thick and still, while warmer air can sit just above it like a lid. This kind of layering, cold below and warm above, creates conditions found in few other places on Earth in quite the same way. It is a landscape built from long silences. Winters are dark for many hours a day. Snow deadens sound, and light gets scarce, so anything glowing against that blackness stands out with unusual clarity. Locals have said the lights seem to prefer this stillness, appearing more often when the air is calm and the sky is clear. Whether that pattern means something about their cause, or simply means people are more likely to be watching on quiet nights, remains an open question. What makes Hessdalen different from a single sighting or a rumor passed through a town is its persistence. The lights have been reported since at least the 1930s, with a strong wave of sightings beginning in the late 1970s and early 1980s, when so many appeared that scientists organized a formal project just to study them. That project and the ones that followed gathered real data, photographs, spectral readings, radar tracks, and still, no single theory has managed to explain every documented case. Some lights behave like weather. Some behave like something else entirely. Consider, for a moment, how rare this is. Most unexplained lights in the sky are seen once by one or two people and then are gone, leaving only memory and no repeat performance. Hessdalen offers something different, a place where the phenomenon seems to return again and again over a span of nearly 100 years, in a landscape small enough to actually study. That combination of repetition and place is part of why this valley has drawn physicists, geologists, and folklorists alike, each bringing a different lens to the same dark sky. Tonight, We are going to sit with that valley the way its own residents have sat with it for generations, not rushing toward an answer, because no one has one yet. Instead, we will walk slowly through what has been seen, what has been measured, and what remains just past the edge of explanation. We will look at the theories, the instruments, the seasons, and the stories, and we will notice, gently, where each one runs out of certainty. There is no need to solve anything tonight. There is only the quiet pleasure of wandering, the way people have wandered in that valley for longer than any of us have been alive, while the mountains stand dark and patient around them, keeping whatever they know to themselves. Let's begin with the simplest question of all. What exactly do people say they see when they look into the dark of Hessdalen Valley? The reports share a common shape, even across many decades. Someone stands outside on a cold night. They look toward the ridgeline or down toward the valley floor. There, hanging in the air, is a light. It is not the light of a farmhouse window. It is not a car on the distant road. It hovers, sometimes for a few seconds, sometimes for close to an hour, in a place where there is no reason for any light to be. Most witnesses describe a glow somewhere between white and yellow, though some speak of a cooler blue-white, and a smaller number describe red. The size, as best anyone can judge from a distance in the dark, ranges from something like a car headlight to something closer to a small house, though distance in a dark valley is notoriously hard to judge with the naked eye. The lights often sit low, closer to the valley floor than to the sky above it, sometimes just above the tree line, sometimes seeming to rest on the slope itself. What makes Hessdalen's lights different from an ordinary strange sighting is their behavior. Many witnesses describe a slow, almost thoughtful movement. The light will drift along the valley for a stretch, then stop. It may hang motionless for several minutes, as if paused, before drifting again or fading out entirely. Some reports describe a light that splits into two, or two lights that merge into one. Others describe a light that simply blinks out, with no streak, no falling motion, no sound at all. This absence of sound is one of the clearest and most consistent details across the record. Whatever moves through that valley, it moves in silence. The frequency of sightings is itself part of the puzzle. In the early 1980s, at the height of local interest, some residents reported seeing unexplained lights as often as 10 or 20 times a month. That is an extraordinary rate for any unexplained atmospheric event anywhere in the world. To put that in perspective, imagine a rare weather event, something like a vivid double rainbow, happening not once a year, but several times a week, in the same narrow strip of land. For years running, sighting rates have varied a great deal since then, with some years bringing frequent reports and others bringing almost none, and no one has fully explained that rise and fall either. Distance estimates from witnesses vary widely, which is part of why the size of the lights remains so hard to pin down. A light, reported as being a mile away, and the size of a house would, if it were actually 5 miles away, need to be far larger to appear the same size. Without instruments, the human eye struggles to judge scale against a dark, featureless backdrop of hillside and sky. This is one of the first honest limits of the whole subject. Even the most sincere witness, doing their best, is working with senses that were never built to measure distant light in total darkness with precision. Local reports go back decades, with some accounts describing similar lights in the valley across much of the 20th century. Though the wave of attention that put Hessdalen on the world's map came later, early witnesses were mostly farmers, hunters, and families living in scattered homes along the valley. They were not looking for anything unusual. They simply saw something, night after night. that did not fit anything they already knew. One early theory, offered almost as soon as reports began to spread, was that people were simply misidentifying ordinary things, aircraft lights, the planet Venus low on the horizon, reflections off distant windows, or even the headlights of vehicles on a road that curved out of view. These explanations account for some sightings, almost certainly, but they struggle to explain the reports of lights that hover motionless for many minutes, that move against the wind, or that appear low against a hillside with no road anywhere near it. A competing view held by some of the researchers who later traveled to the valley was that something genuinely unusual was happening in the atmosphere itself, tied to the particular geology of the ground below. Neither explanation on its own accounts for every report on record. What we are left with at this earlier stage of the story is a set of basic facts that are strange simply for being ordinary. A quiet valley. A light with no clear source. A silence where a sound should be. Nothing dramatic has happened yet. No one has been harmed, and no one claims otherwise. There is only a long, patient record of people looking into the dark and seeing something they cannot name. That plain, sober strangeness is where the real mystery begins. To understand why lights might gather in this one small valley, we have to go back before there were any lights to see at all. We have to go back to the rock itself and the long, slow story of how Hessdalen came to have the shape it has today. The stone under this valley is old. Some of it formed hundreds of millions of years ago, when this part of Norway sat under ancient seas and volcanic activity along old plate boundaries. Layers of sediment and mineral piled up, pressed together, and slowly turned to stone. Later, deep heat and pressure inside the earth folded and changed that stone even further, a slow cooking that geologists call metamorphism. The result is a mix of rock types packed close together, including sulfur-bearing minerals and old copper and iron deposits that miners would find useful many centuries later. Then came the ice. During the last ice age, thick glaciers moved across this part of Scandinavia, grinding over the land like slow, heavy rivers of frozen weight. Ice does not care what is underneath it. It carves through soft rock and hard rock alike, though not at the same speed. Where the stone was softer, the glacier cut deeper. Where it was harder, ridges and shoulders of rock remained standing. When the ice finally melted, around 10,000 years ago, it left behind the long trench we now call Hessdalen, a narrow valley running between higher ground on either side. This shape matters more than it might seem. A valley like this acts almost like a container. Cold air, being heavier, sinks down from the surrounding hills and settles along the valley floor. Especially at night, warmer air can sit above it, forming distinct layers instead of mixing freely. This kind of layering, sometimes called a temperature inversion, is common in valleys around the world. But in Hessdalen, some researchers wonder whether this layering does something more than simply trap fog and cold air. It may also trap gases rising up from the ground, because underneath Hessdalen, the earth is not entirely still. The valley sits near a boundary of old rock formations, and there is evidence of a natural fault line running along its length. Faults are not always the sudden dramatic breaks people imagine. Sometimes they are old, quiet zones of stress and pressure, tiny shifts happening slowly, without any dramatic earthquake at all. One theory, first proposed by physicist Erling Strand, and later explored by other researchers, is that pressure on certain minerals in this stone might generate small electrical charges, a process called the piezoelectric effect. We will look closer at that idea in a later section. For now, it is enough to notice that the very bones of this valley may not be entirely passive. There is also the matter of what lies beneath the loose soil. Hessdalen has a long mining history, with deposits of sulfur, copper, and iron pulled from the ground for generations. Wherever there is old mineral-rich rock, there is often radon gas as well, a naturally occurring gas that seeps up slowly through cracks and fissures. Some researchers have measured elevated radon levels in the area and wondered whether this gas, rising invisibly into the cold night air, might interact with moisture or ions in ways not yet fully understood. Other scientists remain cautious, noting that radon alone has never been shown to produce anything resembling a glowing, moving light. The question of what role, if any, this gas plays remains open. So by the time humans arrived in this valley centuries ago to farm its thin soil and mine its stone, the land itself was already carrying a quiet, complicated history. Ancient seabeds turned to folded rock, glaciers grinding a corridor into the mountains. Geology unusually rich in metal and mineral, sitting along old lines of stress in the Earth's crust. A valley shape that holds cold air still, layer upon layer, night after night. None of this proves anything about the lights themselves. Geology can explain why a valley holds fog, or why certain minerals sit in the ground, but it cannot yet explain, on its own, a glowing shape moving slowly along a ridgeline. What the deep history does offer is a kind of stage, a very specific and unusual set of physical conditions. Unlike most ordinary valleys, whether that stage is enough to produce light, or whether it merely happens to be the place where separate, unrelated forces occasionally meet, is a question researchers are still trying to answer. For now, we simply have this quiet trench of old stone and glacial memory, waiting each winter for the cold air to settle back into place. Winter comes early to Hessdalen. By October, the sun barely climbs above the ridgeline, and the valley spends long stretches of the day in a soft blue shadow. This darkness matters. Most of the light sightings across the decades of record keeping happened between late autumn and early spring, when nights stretch long and the air turns cold and still. To understand the lights, it helps to understand the valley's raw materials first. What is actually in the air and rock here, and how might those materials come together to make something glow? The bedrock beneath Hessdalen holds old sulfide ore, rich in iron, copper, and zinc. Miners worked these seams for generations, pulling metal from stone that formed hundreds of millions of years ago, when this part of Norway lay under ancient seas and volcanic activity along the ocean floor. Metal sulfides settled into layers, pressed and folded over time into the ridges that now frame the valley. This is not unusual geology on its own. Many places have sulfide ore, but some researchers wonder whether the particular mix of minerals here, combined with the valley's tectonic history, creates conditions that are harder to find elsewhere. One idea worth sitting with involves the valley's exposure to natural radioactivity. Certain rocks release small amounts of radon gas, a colorless, odorless gas that forms when uranium and thorium in stone slowly decay. Radon rises from the ground and mixes into the air we breathe every day, usually in amounts too small to notice. In Hessdalen, some researchers have measured radon levels and found them elevated compared to typical background readings. The open question is whether this radon could ionize the air nearby, meaning it could strip electrons from atoms and leave behind charged particles that might, under the right conditions, glow. This remains a hypothesis, not a settled explanation. No one has shown a direct, measured link between the valley's radon levels and the appearance of a specific light. Cold winter air itself plays a role too. Cold air is denser than warm air, and dense air sinks. On a still winter night, cold air can pool in a valley floor, trapped by the surrounding ridges, while slightly warmer air rests above it. This creates layers, almost like the valley is filled with invisible shells of differing temperature and density. Some atmospheric scientists suggest these layers might bend and refract light in unusual ways, or that they could trap gases near the ground long enough for a chemical or electrical process to build. Others counter that temperature layering is common in valleys worldwide, and most valleys do not report glowing orbs. The layering may be a piece of the puzzle, but likely not the whole picture. Water vapor matters as well. Hessdalen sits near rivers and old lake beds, and the air often carries moisture, especially as temperatures drop toward freezing. Fog forms easily here, drifting low across the valley floor in soft grey sheets. Some observers have noted that certain light sightings occurred near patches of ground fog, though many others happened on perfectly clear nights with no fog at all. If moisture plays a part, it is not a consistent one. This inconsistency is one of the quiet frustrations of studying Hessdalen. The materials seem present, but they do not line up the same way every time. Consider, too, the iron and copper pulled from these same hills. Iron formed inside dying stars, forged in the final violent moments before a star collapses, then scattered across space in supernova explosions billions of years ago. That iron eventually became part of the dust and gas that formed our solar system, and later part of the molten rock that cooled into Earth's crust. The copper and zinc in Hessdalen's ore share a similar stellar origin. In this sense, whatever might be happening in this valley, whatever electrical or chemical process may or may not be at work, is happening with atoms that traveled an extraordinary distance and time to get here. None of these pieces, taken alone, explains the lights fully. Radon, ore, temperature layers, and moisture are all real and measurable. What remains unmeasured is how or whether they combine into something luminous. Some researchers propose the valley acts almost like a natural laboratory, with unusual raw materials arranged in an unusual way. Others remain cautious, noting that many valleys share some of these features without producing anything unexplained. The building blocks are here in the stone, the gas and the cold night air. What they build, if anything at all, is still an open question, waiting for a longer winter's watch. People who watch the Hessdalen lights often describe color first. Not the pale yellow of a distant farmhouse window, not the white of a car's headlamp on a far ridge. Something else. A soft white core, they say, wrapped in a faint blue or violet edge, sometimes shifting toward red at the bottom, like a small flame standing still in the cold air. The colors do not always match anything easy to name. That mismatch is part of why the lights have resisted a simple answer for so long. Ordinary light sources have ordinary colors. A flame burns orange or blue, depending on what it is burning. A star's light bends into a rainbow when it passes through mist, split by the same physics that makes a prism work. Sodium streetlights glow a familiar amber. Each of these colors comes from a known cause, a known temperature, a known chemical signature. The Hessdalen lights, by contrast, sometimes show colors that do not fit cleanly into any of those categories. Researchers who have studied the spectra, the pattern of colors a light produces which can reveal what it is made of, have found results that are hard to sort into a single tidy explanation. One idea, and it remains only an idea, points to plasma. Plasma is a state of matter beyond solid, liquid, and gas, where atoms lose some of their electrons, and the resulting mix of charged particles can glow on its own. Lightning is plasma. So is the aurora, that shifting curtain of green and violet light seen in the far north sky. If something in Hessdalen Valley could ionize the air, strip electrons from atoms and leave behind a charged glowing cloud, it might explain lights that hover, drift and shine without any visible flame or bulb. The valley's own geology gives this idea a foothold. Hessdalen sits over a band of rock rich in certain metallic ores, and some researchers wonder whether shifting pressure deep underground could generate small electrical charges that leak upward into the air. That idea, often called the piezoelectric hypothesis, rests on a real property of certain rocks. Piezoelectricity is the ability of some crystals to produce a small electric charge when they are squeezed or stressed. It is not exotic. It is the same principle used in some cigarette lighters and quartz watches. If the valley floor holds enough of the right minerals, and if slow shifts in the ground apply enough pressure, the theory suggests those charges could build, travel along fault lines, and discharge into the air above the valley floor. Once loose in the atmosphere, especially in cold, still conditions that charge might ionize dust or moisture enough to glow. It is a tidy chain of cause and effect, but tidy chains do not always survive contact with evidence. Skeptics of the piezoelectric idea point out that no one has directly measured a charge building in Hessdalen's rock at the moment a light appears. The timing has never been caught cleanly. Others note that similar rock formations exist in many places around the world, without any matching lights, which raises the question of why Hessdalen would be so unusual if geology alone were the answer. The rocks may be part of the story. They may not be the whole of it. There is also the matter of temperature and heat, forces that shape so much of what we see in the natural world. A true flame needs fuel and oxygen, and gives off heat you could feel from a short distance. Observers near the Hessdalen lights, including researchers with heat-sensing equipment, have not always detected the kind of warmth a flame or hot object should produce. That absence is strange. It suggests, at least in some cases, a light without ordinary heat, which narrows what physical processes could be responsible and rules out some of the simplest answers. Then there is radiation. In its broadest sense, the many forms of energy moving through the air that our eyes cannot see, cosmic rays from beyond the planet, background radioactivity from certain rocks, small amounts of radon gas seeping from stone. All of these have been proposed as possible ingredients in some larger, unresolved recipe. None of them alone seems to fully explain a slow, hovering colored light that can sit still for minutes and then glide away. Perhaps 2 or 3 forces are working together, layered on top of each other, rather than any single cause acting by itself. What stays constant through every theory is the sense that ordinary rules of light and heat do not fully apply here, or at least not in ways scientists have managed to isolate and confirm. The valley keeps its own quiet arithmetic, one that resists a clean solution. For now, the colors remain a question mark hanging softly over cold, dark hills, waiting for an answer that has not yet arrived. Let's think for a moment about scale, because scale is where this mystery becomes strange in a new way. Picture a lightning bolt. It cracks the sky in a fraction of a second, and it comes with a sound that can shake the windows of a house 2 miles away. That sound is the boom of air itself, superheated and expanding faster than a rifle shot. Now picture something almost the opposite. A ball of light drifting over a snowy ridge in Hessdalen, moving no faster than a person on a slow walk, and making no sound at all. No crackle, no hum, no hiss of static, just silence, thick and complete, the kind of silence you only get in a valley wrapped in snow. This absence of sound is one of the strangest details in the entire record. Most things that glow brightly and use real energy tend to announce themselves in other ways too. A flame crackles, a power line hums, a plasma torch in a lab roars like a small storm. But witnesses in Hessdalen, again and again across decades, describe the lights moving in complete quiet, even when they pass close overhead. Some report hovering that lasts for minutes, sometimes close to an hour, followed by fast movement that would seem to demand a sound wave trailing behind it. And yet, nothing. Just cold mountain air and a light that seems to belong to no known category of noise. To understand how odd this is, it helps to think in numbers we already know from daily life. Sound from a jet passing overhead reaches your ears within seconds. A deep tearing roar sound from a passing car on a highway carries for a quarter mile on a still night. Even something as gentle as wind moving through pine trees produces a whisper you can hear from 50 yards away. Hessdalen's lights, by contrast, have been reported hovering as close as 100 meters from an observer, roughly the length of a football field, without a single confirmed report of accompanying sound. If this were an aircraft, a fire, or a chemical flare, physics says we should hear something. The silence itself becomes a kind of measurement, a piece of data that rules things out, even as it fails to point clearly toward what remains. Consider size as well. Most sightings describe an object roughly the size of a car or a small house, sometimes larger, hovering low over the valley floor or drifting along the tree line at hillside height. That is a strange middle ground. It is far too large to be a candle flame or a swarm of insects catching moonlight, yet far too small and low to be mistaken for a distant star or planet. Explanations skeptics sometimes raise for light seen much farther away. Hessdalen's lights are close enough that people have watched them for entire minutes with the naked eye, near enough that early researchers could, on rare occasions, get a camera within useful range. Then there is duration, and here the numbers become even more puzzling. A meteor burns across the sky in 1 or 2 seconds. A lightning flash lasts a fraction of a second, but Hessdalen's lights have been documented hovering, essentially still, for periods lasting from several minutes to, in some reported cases, close to an hour. If you have ever tried to hold your arm still, pointing at one spot in the sky for even 5 minutes, you know how long that actually feels. Now imagine something floating in that same spot, glowing steadily for 10 times as long, with no sound, no visible support, and no clear source of fuel. Some researchers have tried to calculate the light output required to be visible at the distances reported, sometimes several kilometers, and compared it to known light sources like flares, welding arcs, or ball lightning. That rare and still poorly understood glowing sphere, sometimes seen during thunderstorms. The comparisons are uneasy. Ball lightning typically lasts only seconds. Flares burn out quickly and make noise as they burn. Nothing in the catalogue of known atmospheric light matches the specific combination Hessdalen offers. Long duration, near silence, moderate size, slow motion, and a location that repeats the pattern across decades rather than once in a lifetime. None of this proves what the lights are. It only sharpens the shape of the mystery, the outline of what needs to be explained, whatever mechanism produces them. If it is a single mechanism at all, must account for a light bright enough to see from kilometers away, patient enough to hover far longer than any flame or spark, and quiet enough to leave no trace on the ear, only on the eye. That kind of stillness, held against that kind of scale, is what keeps Hessdalen resting so firmly outside anything scientists have measured before. Before the scientists came with their instruments and their careful notebooks, there were only the people who lived in the valley. Farmers in Hessdalen worked the land through short summers and long, dark winters. They knew every ridge and slope by memory, and many of them, over many years, watched something in their sky that they could not name. Picture a farmhouse at the edge of a field. Its wood walls silvered by weather, smoke rises in a thin grey line from the chimney. Beyond the fence, the ground slopes down toward the river, and beyond that, the mountains hold the last light of a winter afternoon. A farmer steps outside to check on the animals. He glances up, the way anyone does in a place this quiet, and sees a glow sitting low over the valley floor. It does not blink. It does not move like a plane or a star. It simply hangs there, pale and steady, for longer than seems reasonable. These were not people looking for a mystery. They were looking after cattle and cutting wood and watching weather for the sake of their crops. Their accounts, when researchers later collected them, share a certain plainness. The lights hovered. Sometimes they drifted along the valley, slow and deliberate, as if following the shape of the land itself. Sometimes they sat still above a hillside for an hour or more before fading. Farmers described colors ranging from white to yellow to a deep, unsettling red, though white light appeared most often in what people remembered and reported. What makes these older accounts valuable is their consistency. Separate families, separate decades, describing a similar shape of experience. A light low in the sky, moving without hurry, present without explanation. One theory researchers later considered is that oral memory in an isolated community can blur over time, with newer stories reshaping older ones until they all sound alike. That is a fair caution, and it deserves to sit alongside the sightings rather than be dismissed. Isolated valleys do tend to develop shared ways of describing the unfamiliar, but some of the accounts were written down close to when they happened, in farm diaries and local records. And those early written notes described the same basic pattern that later witnesses would report to scientists with cameras and radar. Stand on that valley floor today, even without a light in the sky, and you can feel why these reports carry weight. Hessdalen is a narrow trough of land, pressed between mountains, with steep slopes rising on either side, like the walls of a long stone hallway. The river below moves quietly over rounded stones. Spruce forest climbs partway up the slopes, before giving way to bare rock and scrub near the ridgelines. In winter, snow softens every edge, and the whole valley takes on a hush that makes any small light feel enormous by contrast. In summer, low sun skims along the mountain tops for hours, casting long gold shadows across the grass. It is a place built, almost by its geometry, to make a floating light impossible to miss and hard to forget. The farmers who watched these skies were not separate from the land. Their livelihoods depended on reading it closely. Some kept records of when the lights appeared, relative to weather, to season, to work in the fields. This is useful because it means the earliest data on Hessdalen's lights was not gathered by instruments at all, but by the daily attention of ordinary people paying close attention to their own home. A shepherd noticing a light above a specific ridge on a still night. A child sent out to fetch water, stopping to stare at something glowing over the tree line. These small human moments built up, one household at a time, into a pattern too broad to easily wave away. Of course, personal memory has limits, and no farmer was equipped to measure the light's temperature or its distance with any precision. Estimating how far away a glowing object sits at night over unfamiliar terrain is famously difficult even for trained observers. A light could be far larger and farther away than it appears, or the reverse. This uncertainty is part of what later drew scientific attention to Hessdalen, because eyewitness testimony alone could describe the experience, but never settle the physical facts. Still, what those farmers left behind was not nothing. It was a foundation. Long before radar dishes and spectrometers arrived in the valley, there were people standing in cold fields, breath visible in the air, watching a light that did not behave like anything they already had a word for. Their sky, layered over rock and river and forest, held a shape of unresolved wonder, decades before anyone thought to study it formally. That surface memory, plain and repeated across generations, is still part of what any explanation for Hessdalen must eventually account for. By the early 1980s, the sightings in Hessdalen had grown too frequent to dismiss as rumor. Local reports counted close to 200 sightings in a single year, spread across a valley that held only a few hundred people. Word reached researchers in Norway who had spent their careers studying ordinary things: sound waves, magnetic fields, the slow chemistry of rock. What they found when they arrived was not proof of anything. It was simply a valley that seemed to be doing something it should not do. The first real effort to study the lights properly began in 1983. A small group of engineers and physicists, working with limited funding and even more limited certainty, set out to build something that had never existed before, a fixed station meant to watch a night sky for as long as it took. They called it Project Hessdalen. The idea was quiet and practical. Instead of chasing a light after someone spotted it, they would build instruments that never blinked, never got tired, and never needed sleep. The valley would be watched the way a scientist watches a slow chemical reaction, patiently and without expecting results on any particular night. The station they built sat on a hillside with a clear line of sight down the valley floor. It held a magnetometer, an instrument that measures small shifts in the local magnetic field. It held a seismograph, the kind of device that normally listens for the shiver of an earthquake. It held cameras, aimed at the sky, some tuned to ordinary light, others built to catch wavelengths the human eye cannot see at all. None of these tools had been designed with unexplained lights in mind. They were borrowed from other sciences and pointed, almost experimentally, at a stretch of dark valley air. What the researchers hoped for was simple correlation. If a light appeared, did the magnetometer twitch? Did the ground hum with some small seismic murmur? Did the cameras catch a shape with edges, or only a soft smear of glow? The answers, when they came, were frustratingly incomplete. Some nights, a light would appear, and every instrument would stay flat and silent, as though the sky had produced something without anchoring it to the ground at all. Other nights, subtle magnetic disturbances showed up with no visible light to explain them. The data almost matched a pattern. It never quite closed the loop. One early theory born from this work involved the valley's mineral composition. Hessdalen sits on rock, rich in sulfur, copper, and iron, deposits that had drawn mining interest for centuries before anyone thought to study lights. Some researchers wondered whether an electrical process tied to this ore-rich ground might explain the readings. A weak natural battery, they proposed, could form where two different minerals meet groundwater, generating small currents deep underground. Whether such a current could ever climb high enough or become bright enough to explain a hovering glow above a valley floor remained an open question, and still does. A competing idea leaned less on the ground and more on the sky above it. Hessdalen's narrow shape and steep sides create unusual temperature layers, especially in winter when cold, dense air can pool along the valley bottom, while warm air sits above it like a lid. Some scientists proposed that this layering might bend and trap light in unusual ways, or create rare atmospheric conditions capable of producing luminous effects, still poorly understood. Critics of this idea pointed out that temperature inversions are common across the world, in valleys and basins everywhere, yet none of them produce anything resembling Hessdalen's recorded lights with such regularity. What made the early station important was not that it answered these questions. It made the questions sharper by giving them shape. For the first time, the phenomenon had a paper trail, timestamps, coordinates, faint traces on instruments that had never been designed with ghosts or folklore in mind. The researchers were careful in their notes not to claim more than the data allowed. They wrote of anomalies, of readings without clear cause, of correlations that fell short of proof. That caution has stayed part of Hessdalen's story ever since. The station on the hillside was small, built with modest tools and modest expectations, yet it marked a turning point. A place, once known only through the memories of farmers and fishermen, had become, almost overnight, a site of formal scientific attention. Beneath the valley's quiet stone and its long winter dark, something was being measured now, even if no one could yet say exactly what that something was. The watching had only just begun, and the valley, as always, kept most of its answer to itself. Once the small station stood in the valley, the researchers faced a new kind of waiting. The lights did not come on command. They did not follow a clean schedule that a person could circle on a calendar. Instead, the watchers learned that Hessdalen ran on rhythms that were only half visible, patterns that seemed to hide just beneath the surface of understanding. The clearest rhythm was seasonal sightings, clustered heavily in the colder months, especially from late autumn through winter and into early spring. During the famous wave of activity in the late 1970s and early 1980s, some residents reported seeing lights several times a week during the darkest stretches of the year. Summer brought long hours of daylight to this part of Norway, and with less darkness, there were simply fewer hours in which a light could be seen at all. But researchers wondered if the season mattered for reasons beyond daylight. Cold air is denser. Cold ground can hold different electrical properties than warm ground. If the valley floor really does generate charge through stress in its rock, then frozen soil and shifting ice might change how that charge builds or releases. There also seemed to be a rhythm tied to the time of night, though this pattern was less consistent. Many reports came in the hours after full darkness settled, roughly between 8 in the evening and 2 in the morning. Some researchers guessed this simply reflected when people were awake and looking. Others wondered if it lined up with cooling patterns in the valley, as the ground released the day's heat slowly into the night air, creating shifting temperature layers that could bend light or stir the atmosphere in unusual ways. Nobody could say for certain which explanation, if either, was correct. Multi-year cycles proved even harder to pin down. Sightings were not steady across the decades. There were years of intense activity when the lights appeared often enough that local families grew almost used to them, and there were long stretches of quiet, sometimes lasting years, when almost nothing was reported at all. This uneven rhythm puzzled the early instrument teams. A weather pattern should repeat with some regularity. A geological process, tied to stress in rock, might build slowly, release, and then need time to build again, the way pressure gathers before an earthquake and then eases. If something like that was happening deep under Hessdalen, the quiet years might not mean nothing was happening. They might mean the valley was simply recharging. The instruments themselves added a strange layer to this rhythm question: magnetometers, which measure small changes in the local magnetic field, sometimes recorded fluctuations on nights when no light appeared at all; spectrometers, which split light into its component colors to study it, occasionally picked up anomalies in the sky's ambient glow, even when human observers saw nothing unusual overhead. This meant the valley might be active in ways invisible to the eye, humming with some kind of energy that only occasionally became bright enough or organized enough to appear as a visible light. If that is true, the lights people see may only be the loudest, most obvious moments of a much quieter, more constant process. Weather cycles complicated the picture further. Certain researchers noted a possible link between the lights and periods of clear, calm air, when there was little wind to disturb whatever process was forming them. Storm systems, on the other hand, seemed to correlate with fewer sightings, though nobody could say whether the storms were actively suppressing the phenomenon or simply making it harder to see through cloud and rain. The relationship between the lights and ordinary weather remains an open question, sitting somewhere between coincidence and cause. What the instrument data made clear, more than anything, was how uneven and unpredictable the whole system truly was. Unlike a tide, which rises and falls with the pull of the moon in a rhythm you could set a clock by, the Hessdalen lights refused to settle into anything so tidy. They seemed to pulse with intensity for a while, fade into quiet, and pulse again years later, without a clear driving force that anyone could identify. Some scientists compared it to volcanic dormancy, a system that builds pressure unseen and releases it only when conditions align in ways too complex to predict. Others thought the comparison went too far, since volcanoes have known mechanisms and Hessdalen still does not. For the researchers standing in the cold, checking their instruments through the small hours of the night, this uncertainty became its own kind of rhythm. Wait, watch, record, and wonder. The valley gave up its light only when it chose to, on a calendar that no equation had yet managed to write down. Some scientists who have studied Hessdalen for years keep returning to one word: plasma. It is a strange word for a bedroom at midnight, but it simply means a gas that has been given so much energy that it starts to carry an electric charge. The sun is made of plasma. So is the glow inside a fluorescent tube. The idea is that something in the valley air might be doing, in a small and mysterious way, what happens inside a lightning bolt or a candle flame, but sustained, floating, and slow. If a pocket of plasma really does form above Hessdalen, it would need something to feed it. Energy has to come from somewhere. One proposal points to the ground itself, to the mix of minerals lying under the valley floor. Another points upward, to the atmosphere, and to the way charged particles sometimes gather near valley walls when temperature layers stack unevenly above cold ground. Neither idea has been proven. Both remain open, sitting side by side in the research, like two paths through the same dark wood. What makes the plasma idea appealing to some researchers is that it could explain several odd behaviors at once. Plasma can glow without an obvious flame. It can shift color as its temperature and composition change, which might account for the shifts between white, yellow, and red that witnesses have described for decades. It can also drift on air currents in ways that look deliberate, even though no one is steering it. A ball of charged gas, pushed gently by wind, could seem to hover, retreat, and hover again, without any hidden hand at work. But plasma of this kind, floating and self-contained in open air, is difficult to produce, and even harder to sustain. In a laboratory, physicists can create small glowing plasmas using strong electric fields, vacuum chambers, or microwave energy. Keeping one alive outdoors, in ordinary air, without a power source, is a very different problem. Free-floating plasma tends to lose its charge quickly and fade if Hessdalen's lights are plasma. Something in the valley would need to be replenishing that charge again and again, night after night. For decades, no one has identified with confidence what that steady source might be. This is where the valley's geology re-enters the conversation. Standing quietly nearby, like a neighbor who has been listening the whole time, researchers have noted that the mountains flanking Hessdalen contain sulfur, copper, and other minerals in an old and complex vein system laid down over millions of years of geologic slow motion. Some scientists wonder whether mild electrical currents could form where different minerals meet, particularly if there is stress or movement in the rock. It is a small speculative idea, but it offers one candidate for a natural battery hidden beneath the valley floor. Whether that battery is strong enough or steady enough to power a hovering light remains unknown. There is a competing view that steers away from plasma entirely. Some researchers argue that many nighttime sightings in Hessdalen and elsewhere can be traced to combustion sources, distant vehicle lights bent and distorted by cold valley air, or aircraft lights seen at unusual angles. Cold air near the ground can act like a lens, bending light and making a distant, mundane source appear closer, stranger, and more animated than it really is. This explanation accounts for some sightings comfortably. It struggles more with the cases recorded by instruments, when radar and optical sensors registered something solid and moving with no known aircraft, vehicle, or fire in the area. The plasma hypothesis and the optical illusion hypothesis are not enemies exactly. They may simply be describing different nights. Hessdalen has produced sightings for so long and in so many different conditions that some researchers now suspect more than one explanation is needed. A valley that has drawn attention for over a century may hold more than one kind of mystery, layered quietly on top of each other, each one occasionally mistaken for the others. What ties these ideas together, for now, is uncertainty held with patience rather than alarm. No instrument placed in Hessdalen has yet captured, in a clean and repeatable way, the exact mechanism that could turn air into light. The valley keeps offering pieces of data, a color here, a movement there, a faint reading on a sensor, without offering the full shape of an answer. Perhaps that shape will come together someday, built slowly from careful nights of watching. Perhaps it will remain scattered, one clue at a time, for a very long while yet. Either way, the valley continues its quiet work in the dark, indifferent to whether we understand it, waiting the way old stone always waits. Beneath the valley of Hessdalen lies a story written in stone. This is a place with old bones, geologically speaking. The rock here formed hundreds of millions of years ago, folded and pressed during a time when this part of Norway was being crushed together with what is now Greenland. Mountains that once stood as tall as the Himalayas have worn down to the rounded slopes we see today. What remains beneath the soil is a mix of minerals that some researchers believe may be central to the mystery of the lights. The valley sits inside what geologists call a rich mineral zone. Copper, sulfur, and iron have all been pulled from this ground. Miners worked these hills for generations, following veins of ore through tunnels cut into the old rock. Some of those same minerals, particularly iron sulfides, are known to interact with electricity in unusual ways. This is where one theory finds its footing. If certain rocks, under enough pressure, can generate small electrical charges, some scientists wonder whether Hessdalen's valley floor might act like a natural battery, slowly building charge until it releases as light above the ground. The mineral content here is not average. Surveys of the area have found unusually high concentrations of certain metallic ores compared to surrounding valleys in central Norway. This is one of the extremes that makes Hessdalen stand apart. Most places with strange light reports do not sit on this kind of geology. The combination of a narrow valley, ancient folded rock, and a dense vein of conductive minerals is, by most measures, a rare setup. Whether rare is the same as sufficient to explain the lights remains an open question. There is another extreme worth sitting with, one that has nothing to do with metal. The valley has also shown elevated levels of radon gas in certain areas, a naturally occurring gas that seeps up from the ground where uranium slowly decays deep in the rock. Radon itself does not blow, but its presence hints at deeper radioactive processes happening below the surface. Processes that release charged particles into the air. Some researchers have proposed that this ionization, the stripping of electrons from atoms in the air, could create the conditions needed for a plasma-like glow to form and drift above the valley floor. Still, geologists caution against tying too much to any single mineral or gas. Many valleys around the world sit on mineral-rich rock. Many have measurable radon. Very few of them produce anything resembling the lights people have reported here for decades. This is the quiet tension inside the extreme facts. The valley may have unusual ingredients, but unusual ingredients alone have not been shown to produce unusual light, not with any consistency that satisfies a skeptical scientist. The dust in the air adds another layer to consider. Hessdalen sits in a region with fine glacial till, the powdery sediment left behind when ancient ice sheets ground the mountains down and then retreated thousands of years ago. This dust can carry trace amounts of metal, lifted by wind and settling back down in a slow, constant cycle. A few researchers have wondered whether airborne mineral particles, charged by some process, still not fully understood, might scatter or reflect light in ways that create the illusion of a glowing object suspended in the air. It is a soft theory, more suggestion than conclusion, but it adds to the picture of a valley where ordinary materials behave in ways that are difficult to fully separate from each other. What makes all of this so hard to pin down is the way these extremes overlap. The rock is old, the minerals are dense, the radon is present. The dust moves through the cold air in slow drifting layers. Any one of these traits, taken alone, might explain a small flicker of light under very specific conditions. None of them, taken alone, explains lights that hover for minutes, change color, and sometimes seem to respond to nearby movement, as some witnesses have described. This is often how mysteries endure, not because evidence is absent, but because the evidence points in several directions at once, each one plausible, none of them complete. The valley holds pieces of an answer scattered through its rock, its air, and its long, quiet history. Whether those pieces belong to one explanation or several remains something no one has settled. For now, the ground beneath Hessdalen keeps its unusual chemistry to itself, offering hints but no clear verdict, patient in a way that only very old stone can be. There is a kind of quiet in Hessdalen Valley that has its own weather, not the weather of storms or snow, but the slower rhythm of air moving through stone. At night, cold air slides down the mountain slopes into the valley floor. This is called katabatic flow, a simple word for a simple thing. Cold air is heavier than warm air, so it sinks. It pools in the lowest parts of the valley like water settling into a basin. Some researchers who have spent long winters at Hessdalen believe this quiet movement of air may matter more than anyone first guessed. A valley shaped like a long trough, with steep sides and a narrow floor, creates a kind of natural funnel. Air does not just fall into it. It also gets trapped there, sometimes for hours, sitting still and cold, while the ridges above stay warmer. This still layer of air is called a temperature inversion. It is common in valleys all over the world, and on most nights it does nothing more than make the fog settle low and thick. But Hessdalen's fog does something that has caught the attention of more than one observer. It does not always behave the way fog is supposed to. Witnesses over the decades have described patches of mist that seem to thin and vanish in specific places, sometimes right where a light has just been seen. Whether the fog is reacting to the light or the light is somehow tied to conditions that also clear the fog remains an open question. No instrument has yet caught the exact moment of that vanishing in a way that settles the matter. There is something almost intimate about this detail, something easy to miss if you are only thinking about the lights themselves. Valley wind, unlike wind on open plains, moves slowly and carries the personality of the land it flows around. It curls around rock outcrops. It slows near stands of birch and pine. It gathers moisture near the river that runs along the valley floor, the Hesje, and that moisture becomes the fog that so often blankets these nights. Local observers have noted, almost in passing, that many of the strongest light sightings come on nights when the air is very still, when the fog sits low and undisturbed, and when the temperature inversion is strongest. A still night is a listening night. Sound and light both travel differently through such stillness. One idea worth sitting with is that this daily rhythm of sinking air, pooling cold and slow-moving mist, may create conditions that concentrate whatever it is that produces the lights, whether that turns out to be some form of ionized gas, a rare atmospheric electrical effect, or something else not yet named. If certain gases are being released from the ground, as some studies of local radon levels have suggested, a still and layered atmosphere would trap them close to the surface, rather than letting them scatter into the sky. Radon is a naturally occurring radioactive gas that seeps up through certain kinds of rock, and its presence in a valley like Hessdalen is well documented, though its precise role in the lights is still debated among researchers. A competing view holds that the wind patterns are simply wind patterns, unremarkable and coincidental, and that assigning them meaning is a case of humans noticing patterns where none exist. This is a fair caution. It is easy, especially at night, in a quiet valley, to feel that the fog is behaving with intention. Fog has no intention. It follows temperature, pressure, and the shape of the land, nothing more. And yet the coincidence of stillness and sightings has been noted often enough across enough different observers and enough different years that it has not been dismissed outright by those who study the valley closely. What stays unresolved is whether the wind and fog are a cause, a symptom, or simply a backdrop. Perhaps the still air does nothing more than make it easier for a distant light to be seen clearly, the way a quiet room makes it easier to hear a faint sound. Perhaps the same conditions that produce the fog also produce whatever produces the light. Two children of the same quiet parent. Or perhaps the two things are entirely separate, and the valley only seems to link them because it holds them both in the same narrow space at the same still hour. For now, no one has traced the invisible thread, if there is one, between the falling cold air, the hush of mist over the river stones, and the light that sometimes appears to hover above it all. The valley keeps this small mystery folded into its larger one, offering it quietly the way it seems to offer everything. A hush before something might happen, or simply a hush. By the middle of the 1980s, the reports from Hessdalen had grown too numerous to set aside a simple rumor. Local residents were not the only ones seeing the lights anymore. Newspapers in Norway had picked up the story, and a small group of researchers began asking a quiet question. Could the lights be measured, not just witnessed? In 1983, a team of investigators arrived in the valley with something the earlier accounts had never had. They brought instruments, cameras with long exposure times, spectrum analyzers to study the light's color makeup, and, most importantly for this part of the story, a radar unit, borrowed and set up on the valley floor to scan the sky above the ridgelines. The idea was simple enough. If something solid was moving through the air, radar should catch it. Radar works by sending out radio waves and listening for what bounces back. A bird returns an echo. A plane returns an echo. Even rain returns a faint one. If the Hessdalen lights were something physical, hovering or drifting above the valley, the radar dish should have found them without much trouble. Some nights it did. The team recorded unexplained radar returns that seemed to line up with visual sightings of the lights. Echoes with no obvious source, appearing and disappearing, in ways that matched what witnesses were seeing with their own eyes. For a moment, it looked as though the mystery might resolve into something ordinary. A drone of ionized air, perhaps. A dense pocket of charged particles, thick enough to bend radio waves back to the dish. But then came the nights that gave the researchers pause. Lights would appear in the sky, bright and unmistakable to the observers standing in the cold, and the radar screen would show nothing at all, empty air. No echo, no blip, no trace that anything was there. Whatever the eye was catching, the radar sometimes could not confirm it existed in any way a machine could register. This mismatch became one of the most puzzling threads in the entire investigation. A light with no radar signature raises an old question in a new form. Does it mean the phenomenon has no solid mass, nothing dense enough to bounce a radio wave? Or does it mean the light is something else entirely, an optical event, a trick of atmosphere, and eye rather than an object floating in three-dimensional space? Neither answer fully satisfied the team. Both stayed on the table. Some researchers leaned toward a plasma explanation, the idea that the lights might be loosely bound clouds of ionized gas, glowing on their own, without needing a solid form. A plasma, in simple terms, is a gas so charged with energy that its particles carry an electric charge, and it can glow with a light of its own. The same basic principle that lets neon signs shine. If the Hessdalen lights were plasma, a radar dish might catch them only when their density crossed some threshold, and lose them entirely when they thinned out. That would explain the on-again, off-again radar returns rather neatly. It would not, however, explain what was creating and sustaining that plasma in the first place. Out in a quiet valley with no obvious power source nearby, other scientists were more cautious. They pointed out that radar itself has limits and blind spots, especially older analog equipment used in remote, mountainous terrain. A weak or oddly shaped object might simply fall below the radar's threshold of detection, on some nights and above it on others, depending on angle, distance, and atmospheric conditions that have nothing to do with the light's true nature. In this view, the missing echoes were not evidence of something ghostly or non-physical. They were evidence that the equipment of the 1980s had not yet caught up to the mystery it was trying to solve. What the early radar work did settle, at least, was that this was not simply a trick of tired eyes or a shared story passed from neighbor to neighbor. Something in that valley was producing effects that both cameras and radar dishes could register at least some of the time. The lights were not myth alone. They belonged, in part, to the world of measurable things, and yet the deeper question remained exactly where it had been before the instruments arrived. The radar had confirmed that something was happening. It had not told anyone what that something was. Decades later, researchers still return to those early logs, still puzzle over the nights when the sky held a light, with no shadow on the radar screen at all. Whatever moved through Hessdalen that season left behind a strange kind of proof, visible enough to be seen by many eyes, elusive enough to slip past the machines built to catch it. By the time the automated station stood watch through its first winters, the researchers had stopped hoping for a single perfect photograph. They had learned, slowly, that Hessdalen does not perform on command, but on certain nights, the cameras did catch something, and what they caught raised more questions than it answered. One recorded event, studied closely by the team from Østfold University College, showed a light that pulsed with a strange regularity. It flashed on for about a third of a second, then off for roughly the same length of time, over and over, like a slow heartbeat made of light. No wind moved it, no sound came from it. Spectral analysis, a method that studies the wavelengths of light to learn what might be burning or glowing, suggested the light contained both dust particles and some kind of scattered sunlight, even though the observation happened well after dark. That combination puzzled the researchers. It did not match a flare, a flame, or a simple reflection. Another case, caught by two cameras positioned at different points in the valley, showed a light moving against the slope of a mountainside at a speed and angle that made simple explanations difficult. If the light had been a reflection bouncing off a physical object, the two cameras should have recorded matching motion from their two positions, adjusted for distance. Instead, the readings did not line up cleanly. Some researchers took this as evidence the light was not a solid object at all, but something closer to a glow suspended in the air itself, without a hard surface for the light to reflect from. These findings sit at the center of a genuine disagreement. One camp of researchers leans toward the idea that many Hessdalen lights are a kind of cold plasma, a cloud of ionized gas, meaning gas, where some atoms have lost or gained electrons and can glow without heat, the way a neon sign glows without flame. If this is right, the pulsing pattern might reflect some internal electrical rhythm within the cloud, expanding and contracting as its charge shifts. It is a tidy idea. It is also, so far, difficult to prove with the equipment available in a remote valley with limited funding. A second camp remains cautious about jumping to plasma so quickly. They point out that pulsing lights, oddly steady intervals, and confusing multi-camera readings can also result from something as mundane as light passing through layers of moving, uneven air, each layer bending and reflecting the glow slightly differently. Combined with the long exposure, times some early cameras required, a stationary or slow light source could appear to behave in ways that look impossible, purely because of how the camera itself was recording it. This is not meant to dismiss the observations. It is meant to show how easily strange footage can emerge from ordinary optics under difficult conditions. What makes these particular recordings hard to file away is that they were not single, isolated frames. They were extended captures, sometimes lasting several minutes, with instruments running at the same time. During at least one of these events, a magnetometer, a device that measures small changes in magnetic fields, registered a shift while the light was visible. The shift was small. It was also unexplained by any equipment malfunction the team could identify afterward. Whether the magnetic reading and the light were truly connected, or whether it was a coincidence of timing in a valley full of natural magnetic variation, from its mineral-rich rock remains an open question the data cannot settle. Even skeptical members of the research community tend to agree on one point. Something physical was present in the air during these recorded events. The cameras were not simply malfunctioning, and the footage was not obviously faked or staged. The disagreement is not about whether something appeared. It is about what that something was made of, and why it behaved the way it did. For the people who have spent years pointing instruments at this valley, nights like these are rare gifts and rare frustrations at once. A gift, because the equipment finally recorded a real event instead of empty sky. A frustration, because each recording seems to rule out one explanation while failing to confirm another. The valley gives just enough to keep the question alive, and just little enough to keep it unanswered. Lying in the dark, it is worth picturing that pulsing light against the black shape of the mountain, flashing at its slow, patient rhythm, caught on film, but not yet caught in understanding. Somewhere in that quiet valley, the instruments are still listening. The mountain keeps its rhythm to itself. If you spend enough winters near Hessdalen, you start to notice something that no single sighting can show you. The lights do not appear evenly through the year. They cluster. Late autumn and deep winter bring more reports than the bright months of summer. This is not a strict rule, and it never has been. But researchers who have logged sightings across the decades keep finding the same soft pattern. Something about the cold season seems to matter. One idea points to the ground itself. Winter brings freezing and thawing over and over as temperatures rise above zero in the day and drop below it at night. That cycle puts stress on rock, especially in a valley like Hessdalen, where old mineral deposits run through the mountainsides. Some researchers wonder if this seasonal freeze-thaw motion might squeeze and shift buried rock in ways that summer's steadier warmth does not. If the piezoelectric idea holds any truth at all, the theory that certain rocks release electrical charge when placed under pressure, then winter could be the season when the valley's stone is under the most mechanical strain. That would mean the lights are not just a nighttime event. They might be tied to a slow, seasonal rhythm written into the ground beneath the snow. But the atmosphere offers its own seasonal story, and it competes for attention. Winter nights in Hessdalen are long and often very still. Cold air sinks into the valley floor and settles there, heavy and calm, while warmer air holds above it. This creates what meteorologists call an inversion layer, a kind of atmospheric lid that traps whatever rises from below. Some researchers propose that this trapped, stable air might let a light-producing process, whatever it turns out to be, linger in place rather than scatter and disperse. In summer, with more turbulent air and longer daylight, any similar process might simply break apart before anyone sees it, or before it has time to grow bright enough to notice against a sky that never gets fully dark. Radon gas offers a third thread, and it does not point in quite the same direction as the other two. Radon seeps naturally from certain kinds of bedrock, drifting up in tiny, constant amounts. Its levels can shift with barometric pressure, with groundwater movement, and yes, with the freezing and thawing of soil. Some researchers have suggested that radon's ionizing effect, its tendency to knock electrons loose from atoms in the air, might interact with humidity or dust to create a faint glow under just the right conditions. If this is even part of the story, it suggests a chemistry that changes quietly with the seasons, following moisture and pressure more than the sharp cold of a January night. It is a theory that fits some sightings and stays stubbornly silent about others. None of these three ideas, the rock stress theory, the trapped air theory, and the radon theory, fully explains why sightings still happen outside the winter months. Reports exist from warmer seasons too, just fewer of them. This unevenness is itself a kind of clue, though nobody agrees on what it points to. It could mean several different processes are at work in the same valley, each with its own season of preference, overlapping just enough to blur the picture. It could also mean the true cause has nothing to do with the calendar at all, and the seasonal pattern is simply a matter of who is outside looking up. Winter nights are longer and darker in Hessdalen, after all, which gives people more hours to notice a stray light in the sky. There is a kind of harmony to consider here, even without an answer. The valley's granite and ore deposits shift with the freeze. The cold air pools and stills after sunset. Radon rises from stone that has sat in place for hundreds of millions of years. The human eye, meanwhile, is most alert to a point of light, exactly when the sky around it is darkest and stillest. Each of these threads moves on its own schedule, shaped by the turning of the seasons, and yet they all pass through the same quiet stretch of ground. Whether they cause the lights, shape the lights, or merely happen alongside them remains an open question, one that decades of watching has narrowed only slightly. What stays remarkable is how patiently this valley keeps its rhythm. Sightings rise, sightings fall, and the pattern repeats itself year after year without giving up its reason. Perhaps the explanation is a single process, waxing and waning with cold and pressure. Perhaps it is many small mysteries, taking turns in the dark. For now, the valley simply keeps its season, and the watchers keep their patience, waiting to see which winter might finally tell them why. When physicists first turned their attention to Hessdalen, they did not arrive with easy answers. They arrived with questions, and those questions have shifted over the decades, the way a slow river changes its course without ever announcing the change. In the early years, many researchers assumed the lights would turn out to be something simple, a trick of the eye, a reflection off wet stone, a known aircraft light misjudged in the dark. But the more the valley was studied, the more that simple story began to bend. One of the earliest formal ideas came from a project called Emblé, launched in the late 1990s by Italian and Norwegian researchers working together. They brought spectrometers, radar, and magnetic sensors into the valley, hoping to catch the lights behaving in a way that fit a known physical process. What they found instead was a phenomenon that seemed to shift its own rules. Some lights gave off a spectrum consistent with a glowing gas. Others showed almost no measurable heat at all, which made the fire idea feel harder to hold on to. Over time, one theory rose above the others in scientific interest, though it never fully closed the case. This is the idea of a low-temperature plasma, a cloud of charged particles that can glow without burning in any ordinary sense. In our everyday world, plasma appears in lightning and in the shimmering curtains of the aurora far to the north. Some physicists began to wonder if Hessdalen's valley walls, rich in certain metallic ores, might create just the right mix of charged dust and ionized air to sustain a small, slow-moving plasma body close to the ground. This idea did something important. It gave the mystery a shape that could, in theory, be tested. If a plasma cloud is being generated by local minerals and electrical activity in the valley floor, then the process should leave traces. Changes in the local magnetic field, a rise in ion counts in the air, a pattern tied to weather, to temperature swings, to the seasons. Researchers began looking for exactly these signs, and some measurements did show unusual electrical readings on nights when lights were reported. But the correlation was not constant, and it was not universal. Some lights appeared with no measurable field change at all. A different branch of physicists offered a competing frame, one rooted less in plasma and more in optics. They proposed that some sightings could be explained by an unusual bending of light through layers of cold and warm air, a phenomenon related to the mirages seen over hot highways or icy lakes in a narrow valley shaped like Hessdalen, with cold air pooling low and warmer air resting above. Light from distant sources could bend and stretch in ways that look, from a distance, like a glowing shape hovering above the ground. This theory does not require anything exotic. It only asks that the valley's air behave the way physics already says air can behave. The trouble is that neither theory, on its own, accounts for everything witnesses and instruments have recorded. The plasma idea struggles to explain lights that behave with what looks like directed movement, changing course in ways that pooled charged gas does not usually do. The optical bending idea struggles to explain lights picked up on radar, since a mirage has no physical mass for a radar pulse to reflect from. Each theory answers part of the record and leaves another part standing untouched, like two people describing different rooms of the same house. What has changed most over the years is not the light itself, but the humility of the people studying it. Early researchers hoped for a single tidy answer. Many now speak instead of a layered mystery, one that may involve several different processes overlapping in the same remote stretch of Norway. A plasma event on one night, an optical illusion on another, perhaps even a third process still unnamed, hiding in the data researchers have not yet learned to read. Physics itself keeps opening new doors. Better sensors, faster cameras, more precise magnetometers, and each new tool adds detail without delivering a final verdict. It is worth sitting with that quietly, the way the valley itself seems to sit through each long winter night. Day, place studied for decades by trained scientists, still keeps something back. The equipment has changed. The theories have changed. The question underneath them, the question of what is truly moving through that cold mountain air, remains as open tonight as it was when the first watchers noticed a glow where no glow should be. Not everyone who studies Hessdalen believes the valley holds a mystery at all. Some researchers look at the same data, the same photographs, the same long nights of watching, and arrive at a much quieter conclusion. They propose that the lights are real, but not rare. They suggest that most, maybe even all, of what people see has a known explanation. It simply has not been sorted out, sighting by sighting, case by case. Car headlights are the most common explanation offered for lights seen at a distance in mountain terrain. A single road winds through parts of the valley, and in clear winter air, headlights can appear to hover, drift, or hang still against the dark mass of the hills. Light behaves strangely across long distances of cold air. It can seem to change color. It can seem to move in ways that defy its actual path, especially when the observer has no fixed reference point to judge scale or speed. A skeptic will tell you that human eyes are not good instruments. They are wonderful for reading faces and catching motion in grass, but poor at judging the distance of a single point of light in a dark, open space. Aircraft lights offer a second explanation, and a reasonable one. Planes cross the sky above rural Norway just as they cross the sky above anywhere else. At certain angles, in certain weather, a distant plane can look like it is standing still. Its blinking lights can appear to merge into one steady glow. The skeptics point out that many early photographs said to show the Hessdalen lights were later reconsidered, and some researchers now believe a portion of them may show aircraft, seen from an angle that made altitude and motion hard to judge. Then there is the matter of stars and planets low on the horizon, when the air near the ground is unstable, layered with pockets of different temperature, star-like bends and shimmers. This is the same effect that makes desert horizons look wavy in daytime heat. At night, in a narrow valley with cold air pooling near the ground and slightly warmer air above it, a bright planet near the horizon can twinkle with a strange colored flicker. Venus, seen through that kind of shifting air, has fooled careful observers before. Some skeptics argue that a portion of the historical reports from Hessdalen, especially the earliest ones from the late 1800s, and again in the 1980s, may describe exactly this kind of atmospheric illusion. But the skeptics face their own open question, and it is a real one. Some of the best documented Hessdalen sightings do not fit these explanations cleanly. Radar and camera systems set up at the valley's automatic monitoring station have recorded lights with no corresponding aircraft, no road traffic, and no bright planet in that part of the sky at that time. The station's instruments have caught lights moving in patterns that do not match the drift of a car on a distant curve, or the steady crawl of a plane. Some events have shown a light appearing at one location and, moments later, at another location kilometers away, with no visible path between them. If it is only headlights and stars, why do these particular recordings resist such a tidy fit? This is where the skeptical view and the plasma cloud view sit uneasily side by side. Both camps agree that many sightings, especially older or undocumented ones, likely have mundane causes. The disagreement is over the leftover cases, the small percentage that instruments captured under careful conditions and that still defy conventional explanation. A skeptic might say that percentage will shrink as measurement improves. A plasma researcher might say it points to something atmospheric science has not yet named. There is also a quieter possibility, one that some researchers on both sides have started to entertain. Hessdalen may not be one mystery, but several, layered on top of each other in the same dark valley. A person standing on a hillside, on any given night, might be looking at a car, a planet, an aircraft, or something the monitoring instruments have never fully classified, without any way to tell which is which, just by looking. The light itself gives few clues. It simply glows, moves and fades, indifferent to which explanation the observer happens to prefer. What remains unresolved is not whether ordinary explanations exist. They almost certainly do for a meaningful share of the reports. What remains unresolved is whether they explain everything, and whether the valley's stubborn, instrument-recorded outliers point to something ordinary that science simply has not identified yet, or something the current frameworks cannot yet describe at all. Under Hessdalen Valley, the rock holds old stories in its layers. Some of that rock is rich in metal ore, laid down over hundreds of millions of years. Some of it holds copper, some holds sulfur, and some holds veins of quartz running through the darker stone like pale threads. This mix is not unusual for Norway, but in Hessdalen it may be doing something few other valleys can claim. One theory, first proposed by researchers looking at the site in the 1980s, centers on a property called Piezoelectricity. That word simply means electricity made by pressure. Certain crystals, including quartz, produce a small electric charge when they are squeezed or twisted. It happens in your kitchen, in the igniter of a gas grill, in the little clicking device that sparks a flame. The question researchers asked was simple. Could the slow grinding of rock deep under the valley, the same kind of pressure that builds before an earthquake, be doing something similar on a much larger scale? Hessdalen sits near a boundary in the rock, where two different types of stone press against each other. That boundary could act like a long buried fault line, slowly shifting under its own weight. If quartz-bearing rock along that seam is being squeezed, even gently, it might generate a weak electric field under the right conditions. Some researchers have suggested that field could ionize the air above it. Ionizing simply means stripping electrons from air molecules, giving them an electric charge. Charged air can glow faintly, and if enough of it collects in one place, that glow might look, from a distance, like a floating light. It is a compelling idea, in part, because it does not require anything exotic. No new physics, no strange particles, just rock, pressure, and the electrical behavior of common minerals working together in a valley shaped almost perfectly to hold the effect close to the ground. Some researchers have measured unusual electrical readings in the soil near known sighting locations. Small variations in the local magnetic field have also been recorded during nights when lights were reported, though not on every occasion. But the theory has real gaps, and the researchers most familiar with it are the first to say so. Piezoelectric charges from rock stress are typically very small and very local, producing enough ionized air to create a glowing shape big enough to see from a mile away, one that can apparently move slowly across the valley floor or hang still for many minutes, is a much larger claim than the basic physics has been shown to support. Laboratory tests can produce a spark. They have not yet reliably produced a floating, colored, self-sustaining light of the kind described in Hessdalen reports. There is also the matter of sound, or rather, the near absence of it. If the lights were the result of some large-scale electrical discharge, similar to a lightning strike, one might expect a crack or a hum, some audible signature of that much energy moving through the air. Witnesses, over the decades, have described the lights almost entirely as silent. A few have mentioned a faint hiss, something like static, but never anything like the sound you would expect from real atmospheric electricity on a visible scale. That silence is itself a kind of clue, though one that is hard to read. It may suggest the energy involved, whatever it is far smaller than the visual effect seems to suggest, or it may mean the mechanism producing the light is not electrical at all, but something else entirely. Something that simply happens to glow. A competing idea, related but distinct, involves the radioactive gas, radon, which seeps naturally from certain kinds of rock. Some researchers have proposed that radon, breaking down in the air, could contribute to the ionization process directly, without needing the piezoelectric step at all. Radon levels have been measured as elevated in parts of the valley compared to surrounding areas, though not dramatically so, and not consistently tied to nights when lights were seen. Like the piezoelectric idea, it offers a natural mechanism without demanding anything supernatural. Like the piezoelectric idea, it has not yet closed the gap between a small, invisible process and a light bright enough to be photographed from a ridge a mile away. What the valley seems to offer, then, is a set of ordinary ingredients: quartz, fault lines, radon, all found elsewhere in the world, without producing anything like Hessdalen's lights in quite the same way. Whether the geology here is doing something rare, or whether it is only one piece of a larger and stranger puzzle, remains an open question. The rock keeps its pressure, the valley keeps its silence, and for now, no instrument has fully translated one into the other. Before we go further into the physics of the valley, it helps to slow down and think about the eye itself. The human eye, in darkness, is a strange and delicate instrument. It is not built the way a camera is built. It has quirks, blind spots, and habits of guessing. Some researchers wonder whether part of the Hessdalen mystery lives not in the sky, but in the soft tissue behind the pupil. Consider how vision works at night. In bright light, the eye relies on cells called cones, which see color and fine detail. In darkness, the eye shifts to a different kind of cell, called rods. Rods are wonderful for catching faint light, but they see only in shades of gray. They also sit mostly at the edges of the retina, away from the center. This means the human eye is, in a strange way, better at catching a dim light out of the corner of the eye than staring straight at it. This single fact changes everything about how we judge distant lights. A faint glow seen slightly off-center can seem to shimmer, or pulse, or even move, simply because the rod cells are working differently than the cones would. Look straight at a faint star, and it may seem to fade. Look just beside it, and it often grows brighter. Some vision scientists suggest this flickering quality, this apparent shifting of brightness, may explain part of why witnesses often describe the Hessdalen lights as pulsing gently, like a slow heartbeat in the dark. Then there is the matter of distance. In daylight, the eye judges distance using many cues: the size of familiar objects, the haze of the air, the way things overlap each other. At night, most of those cues disappear. A single point of light against a black valley wall gives the brain almost nothing to work with. It could be a small light close by, or a very bright light far away. The mind has to guess, and it often guesses based on expectation rather than fact. This gap in judgment is not a flaw unique to any one observer. It happens to trained pilots, trained astronomers, and lifelong valley residents alike. Distance estimation in the dark, several vision researchers note, becomes almost a coin flip once the usual visual anchors are gone. It does not mean witnesses are wrong to trust what they saw. It means the tool they used, the human eye, was never designed to measure such things precisely. There is also the question of motion. The eye and brain are quick to interpret small, steady changes in a light's position as deliberate movement, especially if the eye keeps returning to check on it. A light that simply flickers in brightness without going anywhere at all can appear to drift sideways or float upward, purely because the eye keeps rebuilding its position from memory each time it glances away and back. Some researchers who study Hessdalen sightings raise this as one possible contributor to reports of the lights hovering, circling, or slowly climbing the valley slopes. Other researchers push back gently, noting that some sightings were tracked with instruments, not only eyes, and that instrument data has, on occasion, shown motion that a simple visual illusion could not explain. This is the heart of the open question at this stage of the mystery. It is not that human perception explains everything witnesses describe. It is that human perception cannot be ruled out as a partial ingredient, mixed in with whatever the lights truly are, a real physical light source in the valley, combined with a nervous system built to guess in darkness, might together create reports that are stranger than either cause alone. There is a kind of quiet beauty in this idea. It suggests that mystery is not only outside us, floating over cold Norwegian stone. Some of it may live within the machinery of seeing itself, in the particular rhythm of rods and cones, in the ancient way our ancestors' eyes learned to catch movement in dim firelight and darker forests. The eye that watches Hessdalen tonight carries millions of years of adaptation, built for a very different world. None of this closes the case. Photographs exist. Radar returns exist. Instruments, with no rods or cones at all, have, on certain nights, recorded something moving through that valley air. The eye's tricks cannot explain a signal on a screen. So the question remains layered. One part biology, one part physics, one part something still unnamed. Perhaps the true shape of Hessdalen's mystery is not one answer waiting to be found, but several small answers, each explaining a portion of what has been seen there, quietly overlapping in the dark, like the lights themselves. Long before anyone brought an instrument into Hessdalen, the valley already had stories. The people who lived among these mountains did not have spectrometers or radar. What they had was patience, memory, and a habit of watching the sky change through long, dark winters. Their explanations were not scientific in the way we use that word today, but they were careful. They were built from years of looking at the same ridgelines, the same patches of sky, night after night. In Norwegian folk tradition, lights that moved without a clear source were sometimes called by names tied to spirits of the land, or to the souls of the dead, wandering slowly over familiar ground. Other stories spoke of guardian lights, watchers over livestock or homes, appearing when something in the valley shifted out of balance. These were not fearful stories, most of the time. They were closer to explanations of relationship than explanations of danger. The valley was alive with meaning, and the lights were part of how people made sense of living inside it. It would be easy for us now, with our sensors and our satellite data, to set these stories aside as simple superstition. But that dismissal misses something important. The old stories were also careful records of behavior. They described lights that moved slowly, that hovered, that seemed aware in a way that ordinary fire or lamplight was not. Many of those same descriptions appear again, almost word for word, in 20th century sightings from the same valley. The vocabulary changed. The pattern of observation did not. This is part of what makes Hessdalen so interesting to people who study the history of unexplained phenomena. Not just the phenomena themselves. The consistency across centuries suggests something durable is happening in this place, something that predates cameras and spectrometers by a long stretch of human memory. One idea is that the valley's specific geology, the layered rock and mineral veins running beneath the soil, has always been doing whatever it does, and each generation has simply reached for the explanation available to them. Spirits for one century, plasma clouds for another. The underlying event may not have changed nearly as much as our language, for it has. A competing view treats these old stories with more caution. Storytelling, this argument goes, tends to gather in on itself once a valley becomes known for its lights. Later observers may see ordinary things, a distant lantern, a reflection, a trick of fog and moonlight, and interpret it through inherited expectation. A shepherd who grew up hearing about watcher lights might describe an ambiguous glow with more confidence and more folklore-shaped detail than a stranger passing through. Under this view, some portion of the historical record may reflect cultural memory shaping perception, rather than perception generating a lasting truth. Which portion, no one can say with certainty. What makes this tension worth sitting with, especially at night, is how fragile the whole system of explanation really is. Take away written records, and the story shifts to oral tradition, less precise, but perhaps closer to lived experience. Take away modern instruments, and scientists lose the ability to measure color temperature or duration with any rigor. Take away the folklore, and researchers lose centuries of context that might otherwise point toward long-term patterns worth investigating. Each layer depends on the others to be useful. Remove one, and the picture grows thinner. There is also something delicate in how the valley itself supports this long attention. Hessdalen's isolation, its narrow shape, its distance from major cities and their light pollution, has allowed generations of quiet watching to continue almost undisturbed. If the valley were closer to a large town, with its glow and its distractions, it is possible many sightings would have gone unnoticed, swallowed by streetlight and traffic. Instead, this particular fold of Norwegian land has stayed dark enough, and its people attentive enough, for a genuine long record to form, stretching from old stories to modern data logs. None of this settles the deeper question of what the lights actually are. It only shows how much the answer, whatever it turns out to be, depends on layers of human attention across a very long time. The scientist with a magnetometer and the grandmother telling a story by the fire were both, in their own way, gathering evidence. Neither account is complete on its own. Whether the lights of Hessdalen are one phenomenon wearing different names across centuries, or several different things blurred together by memory and myth, remains an open question the valley has not yet answered. For now, it is enough to notice how carefully people have watched, for how long, and how little that watching has settled. Hessdalen is not alone in its long relationship with unexplained light. Around the world, there are other valleys, other quiet places, where people have watched glowing shapes move without sound for generations. Comparing these places to Hessdalen does not solve the mystery, but it does something else. It shows that whatever is happening here may not be entirely unique, and that thought alone can widen the question in gentle, interesting ways. In Texas, near the small town of Marfa, travelers have reported soft lights hovering over a stretch of flat desert since at least the early 20th century. The Marfa lights drift, split, and rejoin much like the ones described in Hessdalen. Researchers who studied them found that many sightings could be traced to distant car headlights bending through layers of warm and cool air, a kind of mirage called an atmospheric refraction effect. But not every report fits that explanation. Some witnesses describe movement and color shifts that headlights alone do not produce. The mystery there, too, remains only partly closed. In the Pyrenees, along the border of France and Spain, older reports speak of glowing orbs seen drifting over mountain pastures at night. Local shepherds gave them names, treated them as familiar, and rarely feared them. No modern research station watches that region the way Hessdalen is watched now. That absence of instruments is itself worth noticing. It means many of the world's light valleys were never studied closely enough to compare data, only remembered closely enough to become stories. This is part of what makes Hessdalen so valuable to scientists. It is one of the few places where recurring lights have been paired with real instruments over real years. Radar, magnetometers, and spectral cameras have all pointed toward that narrow gap between the mountains. Even so, the equipment has only captured a small fraction of reported sightings. The lights seem to resist steady observation, showing themselves freely to a shepherd walking home and staying hidden for months when the cameras are running. That unpredictability is one of the open questions researchers still cannot explain. Some scientists wonder if geography itself is the shared thread between these valleys. Hessdalen sits over a mix of mineral-rich rock, including sulfur, zinc and copper deposits laid down long ago. Marfa sits near fault lines in the Earth's crust. The Pyrenees are folded by ancient tectonic pressure, the same slow collision of continents that built the mountains themselves. If unusual electrical behavior in rock plays any role in these lights, places with complex geology might be more likely to produce them. This is only a hypothesis, not a proven link, and many geologists remain cautious about drawing too straight a line between rock stress and visible light. Others propose a more atmospheric answer. Valleys tend to trap cold air near the ground, creating still, layered conditions that can distort or magnify distant light sources. If this is the main cause, then Hessdalen, Marfa, and the Pyrenees might simply share a talent for optical illusion, not any shared electrical or plasma process. Yet skeptics of this viewpoint out that some sightings in Hessdalen have shown independent movement, changing shape and speed in ways that simple refraction does not easily explain. The debate continues, calm and unresolved, the way most good scientific debates do. What comparing these valleys really offers is a quiet reminder that mystery is not confined to one small stretch of Norwegian ground. It appears wherever certain landscapes, certain skies, and certain human eyes happen to meet. Some researchers now suggest that Hessdalen may not represent a single unified phenomenon at all, but several different processes overlapping in the same geographic pocket. A piezoelectric charge here, a temperature inversion there, perhaps even simple aircraft or optical effects mixed into the same set of decades-long reports. If that is true, then studying Hessdalen may never lead to one grand answer, but instead to several smaller, quieter ones, each solving one small piece of the larger puzzle. No comparable valley elsewhere in the world has produced quite the same volume of instrument-based data. That fact keeps Hessdalen central to ongoing study, even while nothing about it is fully settled. Scientists return each year with new equipment, hoping to catch the same shifting glow their instruments missed the season before. For now, the valley keeps offering only partial answers, gathered slowly, patiently, across the cold high ground, where the light still chooses when to appear. The lights of Hessdalen do not come on a schedule. Some years bring dozens of sightings, other years bring almost none. Researchers who have kept watch since the early 1980s have learned to expect this uneven rhythm, though they still cannot explain it. A bright season might be followed by 3 quiet winters. Then, without warning, the valley wakes up again. This pattern of silence and light is itself part of the mystery, and it may hold a clue that no one has fully understood yet. Think about what it means to study something that comes and goes like this. A scientist cannot simply schedule an experiment and expect the lights to appear. Instead, the work is more like the work of an old fisherman, watching the water for years, learning its moods without ever fully knowing what moves beneath the surface. The automated station in the valley has now logged decades of data. Cameras click at set intervals through the dark hours. Magnetic sensors record faint shifts in the Earth's field, and radar sweeps the air for anything solid. Most nights, all of this technology sits quietly, gathering nothing but wind and silence. Some researchers wonder if the quiet years and the active years follow the deep rhythms of the ground itself. If the piezoelectric idea holds any truth, the theory that pressure on certain rocks can release electrical charge, then perhaps the valley's stone needs time to build up strain before it can release it again. Slow movements in the Earth's crust, small settling shifts too gentle for people to feel, might take years to gather enough tension to matter. Other researchers lean toward the atmosphere instead, pointing to years when temperature layers over the valley sit just right for ionized gas, if the plasma theory proves correct, to hang together long enough to glow. Neither idea has been proven. Both remain open, sitting side by side waiting for more seasons of watching. It's worth sitting with how strange it is that a modern research station, filled with instruments built in this century, still cannot say for certain why some years give it so much to record, and other years give it nothing at all. In most fields of science, a phenomenon that repeats can eventually be pinned down through steady observation. Hessdalen resists that. Its lights do not fit neatly into a laboratory rhythm. They arrive on their own terms, and they leave the same way, looking further out. It is worth wondering what happens to a mystery like this over long stretches of time. The valley itself was carved by ice thousands of years ago, and it will keep changing long after any of us are gone. Slow forces will keep reshaping the mountains around it. The rock will keep shifting by fractions of an inch each century, and the deep ore veins that some researchers link to the lights, will keep sitting in the dark, unbothered by human curiosity. If the lights truly come from something in the ground, that source will likely outlast every instrument built to study it. If they come from the atmosphere instead, then whatever rare mix of gas and cold air produces them may keep repeating for as long as the valley holds its particular shape, its particular winds, its particular winter stillness. There is something calming in imagining this continuity. Long after today's cameras are replaced with newer ones, long after everyone reading these words is gone, the valley may still light up on certain still nights, glowing softly above a farmhouse roof, or drifting along a ridge the way it always has. Or perhaps the lights will simply stop one day, fading out of the record the way many rare phenomena do, leaving behind only old photographs and patient notebooks. No one can say which future is more likely. That uncertainty is not a failure of science. It is simply the shape of a very old, very quiet mystery. For now, the watching continues. Researchers still visit the station, checking equipment, waiting through cold nights for something rare to appear. Farmers in the valley still glance up out of old habit, the way their grandparents did. The lights, whatever they are, remain part of the valley's rhythm, appearing in bursts and vanishing into long stretches of ordinary dark. Whether future generations will finally understand them or simply inherit the same open question is something no one can yet know. The valley keeps its pace, indifferent to our need for answers, and for now, that patient silence is the only certainty anyone has. After all these decades of watching, what does the data from Hessdalen actually tell us? And what does it leave untouched? The instruments at the valley's automated station have logged magnetic readings, spectral colors, radar returns, and the timing of hundreds of sightings. Researchers have built careful records. They have measured what they could measure. And still, no single number, no single graph closes the case. Consider the spectral readings alone. When light from a Hessdalen event passes through a spectrometer, it splits into bands, the way sunlight splits into a rainbow through a prism. Those bands can reveal what elements are burning or glowing, whether it is calcium or iron or something else entirely. Some readings from Hessdalen have shown patterns consistent with silicon and iron dust, materials found in the valley's own soil. That finding supports the idea of some kind of combusting or ionized dust, lifted from the ground and lit by an electrical charge. But other recorded events show spectra that do not match any expected local mineral cleanly. The data points in more than one direction at once. This is the trouble with Hessdalen, stated plainly. The valley does not offer one phenomenon with one signature. It offers many nights, many lights, and readings that resist a single tidy story. A physicist studying the piezoelectric theory, the idea that stress in quartz-bearing rock can generate voltage, might point to the valley's ancient bedrock as a battery of sorts, slowly charging and discharging across a fault line for millions of years. A physicist studying the plasma cloud hypothesis might point to a different set of readings entirely. Magnetic disturbances that suggest something more like a self-contained, floating body of ionized gas. Both scientists are looking at the same valley. Both are working from real measurements. Neither can fully explain what the other has recorded. That is worth sitting with for a moment, quietly, the way you might sit with any large, unanswered question. Modern instruments are extraordinarily good at measuring known things. A thermometer knows what heat is. A spectrometer knows what light is made of. But an instrument can only tell you what it was built to look for. If Hessdalen's lights come from more than one cause, a mix of geology, gas, and atmosphere braided together in ways that shift from night to night, then no single tool, however well designed, will ever produce one final answer. The mystery may not be a gap in the instruments. It may be a feature of the valley itself. There is something almost gentle in this kind of not knowing. It asks for patience rather than urgency. It is the same patience geologists bring to reading a canyon wall, layer by layer, understanding that some questions in earth science take longer than a single human life to answer. The valley does not owe anyone a resolution on a particular timeline. It has been sitting there, cradled by its old rounded mountains, since long before anyone thought to point a camera at the sky above it. It may keep sitting there long after the current instruments are replaced by better ones. Widen the view even further, and the Hessdalen lights become one small glowing thread in a much larger pattern all across the world. In valleys and marshes and open plains, people have reported similar lights for centuries, each place with its own name, its own folklore, its own partial data. Every one of those places sits on the same restless planet, a planet built from ancient stardust, shaped by the same slow forces of pressure, heat, and electricity. The atoms in Hessdalen's granite, the charge that may or may not move through its quartz, the gases that rise from its soil, all trace back to the same cosmic origins as the atoms in our own bodies. We are, in the oldest sense, made of the same material as the valley we are trying to understand. Maybe that is the quiet lesson tonight. The universe does not divide itself into solved and unsolved with clean edges. It offers pieces, some bright and steady, some dim and flickering, and leaves it to us to notice how much still needs looking at. Hessdalen's data is not a failure of science. It is an honest record of a genuinely difficult question, gathered patiently across generations. The lights may be plasma, they may be piezoelectric discharge, they may be something combining several ideas. No one has fully connected yet. For now, the valley keeps its instruments running, keeps its long winter nights, and keeps its answer just out of reach. Picture the valley one more time, settling into night. The ridges of Hessdalen fold into darkness, soft as folded cloth, and the small river keeps moving under a skin of new ice somewhere above the tree line. Snow holds the last pale light of day, the way a held breath holds air. Nothing is happening, and that too is part of this story, because most nights in Hessdalen are simply quiet. The lights do not need to appear for the valley to feel full of something unspoken. We have walked through the theories together. The piezoelectric rocks, quietly straining under old pressure, perhaps releasing charge into the cold air. The plasma clouds, glowing shapes that might hold together through forces we do not fully understand. The radon gas, rising invisibly from stone, may be charging the air into something that glows. The simple, human explanations too: headlights bending through fog, planets sitting low and bright above a ridge, eyes doing what eyes do in the dark and the cold. None of these ideas has closed the case. Each one explains a piece, and the whole keeps slipping past our hands like water. Maybe that is because Hessdalen is not one mystery, but several, layered together in the same quiet ground. A geological process here, an atmospheric condition there, a human mind, tired and hopeful, filling in the rest. Or maybe there is a single answer waiting, one we have not yet found the instruments to catch. Researchers still come back every year. Cameras still watch the dark ridgelines through long winter nights. The valley keeps its own schedule, showing itself when it wishes, disappearing for months, then returning with no explanation for either its silence or its light. There is something soothing in that if you let it settle. Not every question needs an answer tonight. Some questions are simply good company, sitting quietly beside us while other things fall away. The lights of Hessdalen have moved over that valley for longer than any living witness has been alive. They will likely keep moving long after we are gone, whether or not we ever learn what they are. The not knowing is not a failure. It is a kind of gift, an invitation to keep wandering gently, the way you might watch a lit window across a dark field without needing to know exactly who lives there. Think, for a moment, of the whole slow-turning world beneath you now. Somewhere it is daylight, and farmers are walking fields much like the ones near Hessdalen, past and future both folded into the same tired soil. Somewhere the tide is pulling back from a beach, leaving smooth dark stones to breathe in cool air. Somewhere snow is falling, without a single witness, filling old footprints, softening every edge until the ground forgets what shape it used to be. The planet keeps doing this, quietly, whether or not we are watching. It does not need our attention to keep spinning through its long, patient night. You do not have to solve anything before you sleep. You do not have to choose between the plasma and the piezoelectric stone, between the folklore and the physics. You can hold them all loosely, the way you might hold a small stone from a beach you visited once, warm from your pocket, its story unknown and unimportant, next to the simple fact that it is smooth and cool and yours to keep for now. Let Hessdalen stay unfinished. Let the valley keep its secret a little longer. There is no rush. Let your breathing slow, the way fog settles into a valley floor, filling the low places first, softening every hard edge of the day. Somewhere, right now, a light might be moving low across a snowy ridge in Norway, unhurried, uncertain of its own nature, watched by no one at all. That is all right. The world does not need an audience to be beautiful. It only needs to keep turning, steady and slow, carrying all its unanswered questions like stones in a deep, calm river. Rest now. The valley is quiet. The stones are cool. The lights, if they come tonight, will come without asking anyone's permission, and they will leave the same way. You do not need to keep watch. You only need to close your eyes and let the whole vast, patient, unexplained world hold you gently until morning. Subscribe for a brand new Earth topic every night. One tap and something wonderful is waiting for you tomorrow. Sweet dreams.